Hello everyone, welcome to our next ISTE Encore presentation. And for this presentation, we will be having Chris Lukes, who will do an encore of the presentation, Hackathon, Hack Your Class, that he did at the Mobile Learning Playground. So we'll let him go ahead and get started.
Sure. Hello, everyone. I'm Chris, and what we're going to talk about today is a hackathon project that I went ahead and did through a internal grant with our system. But I'm going to talk a little bit about the hackathon and what we did, and then I'm also going to go ahead and talk about how you can use it in your class as well. So I'll go back to the slides now. All right. So hackathon, hack your class. So the first question everyone has is, what is a hackathon? Some of you may know it, and some of you may not. So really what it is a combination of words, or a portmanteau, or portmanteau, depending on how you want to pronounce it. But basically the idea is hack. So it's used in a sense, playful sense. Exploratory programming, it's not, there is an alternative meaning, but we're not using that one. It's starting to be more accepted as a playful experimentation programming style, as opposed to, we're going to go ahead and hack a computer server. And then also a combination of marathon, which is typically reference to the length of time it takes. Most hackathons are typically 1 to 2 days, but it can also go all the way up to a week as well. So there are very long stretches for hackathons. Really what it's all about is working intensely for an extended period of time on a specific problem or project. So the idea is you get everyone together, everyone just focuses on this one problem, or maybe it's a handful of problems if you have a very large group of people. Again, it's a group. These can be anywhere from 6 people all the way through hundreds and thousands of people. And what you do with a big, large group is you break them out into different working groups. So typically, people will present ideas, possible solutions. People then will vote on which are the top or best solutions. And then people will then go ahead and decide to dedicate their time on what project appeals to them the most. It's typically what you see at the very large hackathons. Usually it's overnight. It can be, a lot of them are in the 24 to 48-hour range. And as always, as I said before, there's a common goal. For what we did is we ended up having 3 hackathons over 3 semesters. So what we did is we targeted pieces for our computer science classes. So for us, it's Computer Science 160, it's Computer Science 1. We also looked to introduce other places as well. So what we found and what we initially thought were that it could actually be expanded to a lot of other groups and disciplines. And some of the later ones we did open up to other disciplines. So some places that you might look for additional participants are businesses, so to help with marketing and product promotion, multimedia graphic design, to help with digital assets, and other areas that support programming type of projects. And it all depends on the type of project that you're doing. And we'll talk a little bit about that when we talk about what our students ended up doing and what we ended up doing with our 3 hackathons. So we experimented with hackathons. We played around with it as far as different time lengths. And the things we had in common is basically we based this into the classroom. So this was for face-to-face as well as fully online. Students were involved in this. And what we did is, in addition to the existing curriculum, so we normally taught them C++ was the language that we normally teach in our Computer Science 1 class. We then go ahead and we would offer a live event for our students. And we also had faculty come in and serve as mentors and participate as mentors, as to allow our students to bounce ideas off of and to sort of help jog their memory or sort of point them in a direction whenever they got stuck. Now, the key thing here is that our faculty mentors did not give them the solution. They did direct them where they could find the solution or some possibilities, but the students did the work themselves. And so basically, they said three events or 3 semesters. The first event was 24 hours, the second event was 12 hours, and the last event was 8 hours. So first event, 24 hours. As I mentioned before, we used C++, and really what the focus here was to go ahead and use XML output from our learning management system. So for us, what it is we were trying to address a pain problem. which was for our learning management system, it requires a lot of our faculty members to do multiple clicks to change dates on things from semester to semester. So what I'm talking about is like changing the dates and updating the dates for quizzes, for discussions and due dates, things that all instructors do every semester. When you're updating your syllabus, we have to do that in an online class, and also for our face-to-face class, they are also using our online component as well to supplement the class. So that's really sort of what the main project was there. So again, we had students from our Intro to Programming class as well as our Computer Science class. And really, so sort of what we saw there was snacks, no sleeping, because it was a 24-hour event, lots of coding, and lots of collaborating. So it was a really cool experience to go through. The second event was a 12-hour event, an intense Saturday session. And really, we focused on feedback. So it was a game-focused because that's what we got from the feedback from the first 24-hour session. We asked students what they wanted to do next, and almost to every single one of them said, we want to build a game." I was like, "Okay, cool." So we went ahead and made it a game focus. It was very student-driven, and during the 12-hour event, the students designed a wireframe for their game. So they actually built a rough estimate of what the game is. And the third event was an 8-hour event. It was an intense 8-hour Saturday session again. And this one focused on Minecraft modding. And the reason for this is that a lot of our students at that point in time, again, this was over 3 semesters, so we had a lot of students come back each year, I should say each semester. And they also were interested in applying their Java skills now. And so they were looking at Minecraft and how to build Minecraft mods. So this is our flyer for it. So we had a little creeper there sneaking in the background, just trying to break its way through. The previous one must have exploded. And so we went ahead and had them set that up. So how do we incorporate all of this? We added pieces into our existing curriculum, like I said. So really what we did is we offered the Hackathon event as an alternative to a class project. So they had one option to do this, or the other option was to do this. And we really sort of laid it out because we knew that some students, especially in our online, weren't necessarily located close to where we were going to have this at. We had all of these up in the Fort Collins area here in Colorado. And but basically we gave them as an alternative class project. And the traditional classroom, sometimes it was required and sometimes it was an alternate. Events occurred the last half semester. The reason why we targeted the last half semester was because at that point in time, we've gotten over most of the period of the class where students are actually learning the language, and now we're getting to the period where they actually have a good foundational knowledge of the language and can now build off of that. And so that's why we always targeted the last half of the semester. The other thing that so I'm switching gears now. I'm now talking about for what you need to do whenever you go ahead and set up your own hackathon, and some of the thought processes behind there. I see we do have a question. Question is, do students receive a grade for their work in the hackathon? The answer to that was yes. We did go ahead and have an assessment from the classroom. Basically, it was set up as a project. We set up a rubric ahead of that, so students would know. They looked at their participation. We had peer reviews as far as going ahead and having each group rate the students' participation in the actual project themselves. So we had some peer grading involved as well. So the next question I see coming up is, do you involve the technology community at all? Software vendors, game companies. The answer to that is yes, we did. We actually had a company come in and for the first 24-hour session, because that had the most time, and they went ahead and they actually went through their they're actually looking for coders. They're looking for people to they're looking for a programmer to hire or do an internship with them to go ahead and help them with their product. And what their product was is they worked a lot with alcohol distributors and to help manage their inventories. And so what they did is they provide a product that helps really give them a lot of real-time data for that, and they're looking for going ahead and having having the students look at how they set up their model and how they can go ahead and interact with one another.
Okay, and I guess I just wanted to jump in there because it is our first hackathon. It was very fortuitous because the company that came in actually does manage inventory, but the real reason that they get hired and they get their jobs is because someone has an inventory system already, and they have to piece whatever inventory system and whatever software they're using into a better system. And sometimes the different distribution places have cobbled 3 or 4 together, and they get code from all over the place, and they have to figure out how it all works together and has to get it start functioning. And it worked really well because the learning management system that was used for our first hackathon, the first thing the students were able to do when we opened up and looked at the code for the learning management system is they got to see that the reason why things weren't working so well in it was because it was obvious that different groups of programmers had worked on different sections, and the thing that the calendar wasn't necessarily talking to the calendar wasn't necessarily talking to the news items and the assignments. And so the students, after hearing about this company, really that their bread and butter and how they and really their business model was trying to make what people had not done well much better and integrate things together. It was great that the first assignment that was worked on, the first thing that they did at the hackathon was trying to improve the LMS we were using, and the LMS had these components that it was obvious that the pain that they were trying to fix was the problem. And the reason I even jumped in here, otherwise Chris would have done by himself, but I was assigned as the assessment specialist to this hackathon project, and it was my purpose there was to see where the learning was happening and to assess the learning and then align it back to our common core. And this just worked wonderfully, having this group from the community come in, this company this company that does management, and the students were able to see exactly why that kind of company existed. And so I'll turn it over to Chris now.
Thank you. Yes, definitely. That was one of the interesting things that the students had to overcome was dealing with some issues with modularity in the software industry. And we'll talk a little bit about that a little bit further on in the presentation here. But that was one of the big things that was really cool was we did have the community involved. We did have people come in and sort of give a presentation there. And actually, they were looking for programmers. So other things to look at for your goals is you should have goals for planning your hackathon. So when you're looking at planning your hackathon, number one thing is you have to have the goals. What are the outcomes you want to achieve? What is the thing that you're looking for? Next thing we need to do is go ahead and look at considerations of time, space, food, building access, security, computer and internet access, programming language, and compiler. So there are some other questions coming in, but I am going to delay answering them until we get to the actual page where I actually go ahead and address that. So the goals for us. Example of some goals we had was that better retention of Computer Science 1 to Computer Science 2 students, a higher student persistence and success in computer science, and improved student performance. Those are sort of our primary goals that we're looking for. You can tell that an administrator wrote this because I'm an administrator. And that's one of the reasons why we went ahead and wanted to do these hackathons and tests, because what we found in our computer science classes was the retention wasn't quite where we wanted them to be. And we also really had never necessarily looked at what is the progression of students going through our computer science classes. As you can see from this picture here, we are a community college. This happened at a community college in Colorado, and so our students range all the way from traditional age students all the way through. So we had some gentlemen in their 60s. So we had quite a good age range and distribution when it came to our classes. Our secondary goals were really sort of things that were a bit more quantitative. You know, are the students more excited about pursuing a degree or a career in computer science? Did students develop a big picture understanding of programming in relation to the professional or open source world? Did the computer science enrollment increase during the pilot project? And so those are some different ways that we are looking at what are the things we wanted to measure. So when it comes to space, campus and school space is much less expensive. So all of our events happened on our campus, which significantly reduced our cost. And that's one of the biggest reduction in expenses you can do is host it on your school or campus. If you go off-site, unless you can get someone to donate you space and infrastructure, then that's going to be probably your biggest cost other than food. So students liked being in a familiar place. They were able to scout out the rooms ahead of time. They already knew where the plugs were, the most comfortable seat was, where the broken seat was. They knew where everything was in there. We also made sure that there was a quiet space for people to rest if they needed it. So they felt if they're getting overwhelmed, it was a place where they can go and relax for a little bit. Or if they needed to sleep, especially for doing the 24-hour plus place, then we had a place for them to sleep. In fact, we actually had 2 rooms for crashing rooms, where one was for males, one for females. We had appropriately gendered faculty who was observing those, and the rooms were locked so that way basically only the faculty could let people into the room. And once the students were done, they could just go ahead and leave the room. And there was some supervision there as well. So the other big consideration for hackathons is white space. Lots and lots of whiteboards. People like writing on things. You need to write things out. So whether it's big post-it notes, whether it's whiteboards, if you have a place that has lots of open windows and lots of glass, you can actually take a dry erase marker and you can go ahead and you can use the glass as your whiteboard. So there's lots of different places that you can go ahead and set things up. We have a question here about what is the male to female ratio in participation. I will say that predominantly it was male. That's what we see in our classes. We're trying to get more women into computer science and the programming languages, but predominantly we had some women, as you can see in some of the pages. It was interesting enough as we basically had a 50-50 ratio of male to female faculty mentors. So that was really good. But when it came to our student body that attended, predominantly it was male. We did have some women attend though. So the other thing you see here is you can see the groups. So they would group up. The other thing we used is space-wise is we used our computer lab. So there's a question about was everything wireless? Was equipment BYOD? How did you ensure the infrastructure? That was because we did it on campus. So we reserved a computer lab that you can see here in this image here. So students were able to work in a computer lab that they were familiar with. Students were also encouraged to bring their own laptops if they needed to, but predominantly what we found with our students is that they used the desktops for the most part, at least for the first 2 hackathons. When we got into Minecraft, a lot of the students brought their own computers with Minecraft because they were more comfortable on their own computers. But they did use the same compiler that they were using for their classes. So the infrastructure was all provided by the college. We didn't have to necessarily worry about bringing in outside vendors or mobile hotspots or things like that, which are all considerations if you are going to go off-site. So that's something to really keep in mind. So great question. We also had a breakout room, so they could go out and have food, or they could go ahead and talk or get away from the computer screens for a little bit. We found that students just moved in and out. Students formed groups, so basically what happened is we worked on one problem. The students took on different processes. So in this case, this is from the 24-hour hackathon, and basically students were working on the quizzes. So one group was working on resolving the quiz dating issue. The other one was working on trying to resolve the discussions dating issue. And some others were working on just the overall programming to create the middleware that would basically bring in the XML input and then push out a new XML output that could then be uploaded into the LMS that would automatically change the dates and reduce all that clicking. Because remember, the pain point was everyone having to mouse click about 30 times to get dates changed. So this is sort of a little breakout area we have. Food, as I said earlier, we were funded by an internal immersive learning grant by the Colorado Community College system. We had our events catered, so we were able to get some food delivered. For the 24-hour hackathon, we did basically a dinner. We started at 5 p.m. in the evening on a Friday, and we wrapped up at 5 p.m. on a Saturday. And basically, we had dinner, we had breakfast, and then we had lunch delivered. We also had salty snacks and different things like that throughout the time. So we also had donations, though we did have a donation from a local energy drink company. So we did have some local donations. So that's definitely a way that you could reduce your costs, is to go ahead and look for donations, look for sponsorships locally. When asked, the students said they would have been fine with a potluck or just simply doing a break. There's a lot of hackathons out there where they just schedule that they don't really schedule a meal break. They just say, hey, whenever you're hungry, go out and grab food. And usually the groups figure out and manage that themselves. It is very, the other thing we saw was, food is very time dependent. Basically, the rule of thumb is every 4 hours, provide them food. So that way they can, and what I mean by that is provide them a meal. So it could be sandwiches, it could be, people could do a potluck, it could get pizza delivered. So there's all those different things there. We had barbecue, so that was the meal that everyone liked. There's also, as you would pretty obvious, there's a big difference between a 24-hour hackathon, the food needed, and doing an 8 or a 12. So as I sort of alluded to, a 24-hour hackathon, we did 4 snacks. So we had 4 periods where we just refreshed the snacks. The snacks were always available in the break room as people needed. There are 3 main meals, so dinner, breakfast, and lunch. Lots and lots of Mountain Dew, so lots of sugar, lots of caffeine. There's some energy drinks that we had, and lots of sugar. This is actually for their coffee, but it's kind of interesting to think the students are actually just mainlining raw sugar. But actually, what we found out was that this is what we initially thought they would want, but actually a lot of them wanted water. So again, it's all different preferences. So you can have a diversity of drinks that were there. The cool thing was is a lot of our stuff could be carried over to the next one. So the 12 and 8 hour hackathons, we provided 1 meal, so typically it was like a lunch, and then we provided snacks, so like a mid-morning and then an afternoon snack is sort of what we did for those 2 hackathons. Now here's something that a lot of people don't think about whenever they're planning their event, a hackathon event, is building access. How can people get in and out of building? So for us, we had to make sure we paid for an overnight security guard for the 24-hour session. However, for the 8 and 12, we did not need to do that, so because that was their normal course of coverage. So if you are going to do an overnight session, you are going to have an added security cost to that to ensure that basically so people don't get locked out of buildings, and also just general security as well. So this is the building that we had. So what was interesting in this is we had, like I said, we had the entrances, and the policy was the outside doors were locked after a certain period of time. So that's one of the reasons why we had the security guard around, was in case students got locked out because they wanted to go take a walk or they wanted to go out for a break. They could come back. They wouldn't be able to get back in unless someone would let them in, and we weren't allowed to prop the doors open. So a computer access, internet access, is that you do want to have that. So that way your students can do a lot of preloading as well as going ahead and accessing online resources. So those are some things to think about, is how much do you want to do it. Now, with some of the game coding, you can totally do that without the internet, because you can just code it on the machine and then use a jump drive to move it around if you wanted to. But we made sure that we had computer access because we wanted to give our students access to any sort of online resources they wanted to go ahead and grab. As I said before, it was BYOD, and we would go ahead and allow students to bring in their own laptop, but a lot of them ended up just using the actual, going ahead and using the actual computers on campus. So we do have a question about physical activity breaks. We did sort of try to give them, get them to get up and walk around every 4 hours at least to try to give them that 15-minute break. So that's one of the things that we were doing is basically we were trying to go ahead and get them every few hours to go out, but actually we didn't have to really do that. A lot of our students self-policed, and so they would work intensely for a while. when they got stuck on something, instead of just repeatedly banging their head against it, they would go for a walk. They would just go walk over to the faculty mentors and sort of chat with them. So they would go ahead and they sort of did that themselves. What I found, and again, we were dealing with older students, so community college level students, so they were able to do a lot of ensuring they all got their own breaks, those that wanted them. And so you can see here that a lot of them use the computer. What's interesting in this picture is this book right here. This book is not the book used in the course. This was a reference material that students brought with them. So a lot of students brought their own references, and I will say that that's not uncommon in other hackathons that we saw, is people bring in external resources all the time, and they use web resources, which is another reason why you want to make sure you're providing internet access if you can. So BYOD, well, yes, BYOD. Students brought in their laptop. Again, it was mostly prevalent during the last hackathon, which was more about modding Minecraft. And the reason for that was they were more familiar with using Minecraft on their own computers, and so they just liked the familiarity of the interface. The other big thing for hackathons is you need to make sure you go ahead and you pick a common language and a compiler ahead of time, especially if you're dealing with a lot of adult learners. And it also will simplify your life with younger learners. Now, younger learners, you have an advantage here because you're probably teaching them this already, and so by default they're there. When you start working with post-secondary and adults, a lot of them will have their own favorite language and their own favorite compiler. So as an organizer for an event, you're going to want to make the decision is, do you want to control what language they use or the compiler? Some hackathons do that, some hackathons don't. It really depends on what your focus is. If you're just doing like an app hackathon or a gaming hackathon, they can use whatever language and compiler they want. But if you're specifically doing something like, say, you're going to hackathon by Microsoft to create apps for Microsoft products on a Windows system, you'll want to use the appropriate language and the appropriate compiler, otherwise it won't work. So that's just what we've seen from other hackathons and our hackathons. The third event was a deviation from this. However, we did use the Eclipse compiler still, and we used the Java language. And the reason for that was because the Minecraft modding requires you to go ahead and use Java. So the Eclipse compiler is something they used in class. So we use that. Anybody can use it. It's actually a pretty good workstation for you to go ahead and do that. Here's an example of what the compiler looks like. They have lots of different options and tools to play around with. Obviously, this is a picture that's up on a smartboard, so you get a little bit of reflection. You also see some of the coding that's there. This is a picture of some of the coding that went into developing their game. So this is from the 12-hour hackathon, which was interesting because the group broke itself out. They decided they wanted to do a swordboard game, and they broke themselves out in the team. So one team focused on the level, which was basically designing the map, the course map, designing the map and the environment the player was going to use. And then another team worked on attacks. So you see here it says void player attack, void player defend. They picked classes, so the attacks were just simply the mechanics of how your player versus any sort of enemies would interact with each other, and they also created classes. And the last group focused on what loot the players would get. So how would they get loot? How was loot determined? What was the probability of drops? So lots of math, lots of statistics, lots of coding. So what should you expect? Well, if you do a 24-hour hackathon, you might have students pass out. So there will need to be a crash pad, so give students a crash pad. But a lot of our students actually didn't go to sleep. A lot of our students stayed up. They kept going through the whole thing, and they were actually relatively fresh the next day as well. So a lot of that was because they sort of managed themselves. And one of the things we'll talk about is sort of the different modes, and sort of the natural workflow that's set up. Lots of whiteboard writing, and here's the other key thing. When you're writing something down in a 24-hour hackathon, don't erase it. Just strike it. Just do a strike right through it. And the reason for this is an example of some of the problems the students were dealing with the 24-hour hackathon. This is an example of how we wanted the actual date formats to show up, but this is not the example of actually what happened in the actual coding when we got into the different modules of the learning management system. What we found out is some were this format, some were basically month slash day slash 4 year. Some was simply month slash day slash 2 years, like 02, 05, whatever. And so they're all mixed up and all mixed and matched, and so they had to figure out a way to get middleware to work. So the other thing you'll see while you're there is you'll see Batman. Batman made a relative lots of appearances in our hackathon. So it's just the students letting out some creative energy and figuring out where pieces were at and setting things up. So we have a question here as far as how many students opted for the hackathon assignment rather than the other traditional option. I will say for the face-to-face class, it was a much higher percentage. I would say we had probably 60 to 75% of the class came to the alternate event. For the online class, it was a smaller percentage, just simply because a lot of our students really weren't able to travel the distance, so they opted to work virtually and stay away. We did sort of try to bring in more virtual components to it. But we had a much larger percentage of traditional students and traditional face-to-face come to the hackathon because they were just geographically located closer to the event. The other thing we saw was lots of student leadership. So this is an example of one of our lead students, and he actually involved bringing in a lot of basically visual cues for our other students. So obviously, we said Batman shows up a lot. So the red fez was creative time. It was really sort of where students could visually see, okay, I'm encouraging you all to be creative. I want everyone's ideas. I want everyone to go ahead and do that. And this was a student who came up with the idea for the game for the second hackathon, that they liked his idea for the game, and so he just sort of took on the natural project leader role. And so he was doing that. The blue bowler was when it was go time. So whenever it was time to get down to business and knock things out. And so he really did a good job of, and again, he self-managed it himself as far as how much creative time versus how much go time. And so it was a really good mix that was there. The other big thing, celebrate successes. This is an example, blurry photo, although it is, of what the actual level looked like. So what your character came in is your character to come in and basically as a little X, and you would just move your character across this screen. And again, this is the wireframe. And as you moved in, the more you moved in, the higher probability of running into a creature you did. And you would just keep moving. And so what was interesting about this is their final boss had the truly intimidating name of Vicky. And you could probably guess that that's actually the name of their instructor. The main instructor was there as well. So let's really celebrate those successes. Also, make sure you build in time for problem solving. We had a lot of group problem solving where we would just get the whole group together to try to solve one problem if it was a particularly thorny issue or something to try to figure it out. So we had lots of people working in here, talking to each other, and so you can get a good feel for the diversity of the group as well as, looking and seeing as far as what they're all looking at. And so what you have here is the instructor's up here up front. She's sort of working as a mentor. She's on the instructor computer. Everyone can see what's going on over here on this smartboard here. You can see we've been writing a lot of stuff on the whiteboard, and then a lot of our participants are out here just sort of talking what's going on. It was funny, this gentleman was actually looking stuff up on the internet and randomly giving everybody different ideas or different codes that might work. The other big thing we saw was the huddle. The students would break themselves out into a group, and this is what I meant by self-management. So typically what we saw was one student would be sitting at the controls and coding, and then everyone else would sort of be forming a circle around them. So what you see here, this is a working group right here. This is another working group on the other side. This is a working group here of 3 to 4 students. And then this is sort of that big huddle we showed you earlier where students were asking questions. And so really what we saw was students would interchange. So one student would do the coding, and other students would sort of form this semicircle behind them so they could all see the actual screen and what was going on. And then what we would do is they would switch. So when the coder got tired or their hands started cramping up, then another person would jump in. And so that's what we saw here with the Huddle, is that people would actually go ahead and manage and work around with each other. So what did we learn? One of the interesting things that we saw was that the 24-hour session, there's actually a lot more networking and relationship building opportunities that were taken advantage of in the 24-hour session. Students really got to know each other. Students really got to go ahead and learn about each other and everyone's strengths and weaknesses, and sort of be on a much better footing after the event than they were before the event. You know, before the event, a lot of them hung out in their own little groups of friends and people they knew, but after the event, they all sort of, you know, talked to each other and interacted with each other and a lot more in depth than they did before. In the 12 and 8-hour sessions, there was much more focus on intensity on the coding and less on the relationship building or networking. Students really didn't get to know each other as much in the 12 and 8-hour sessions. Everything was focused on the coding and development of the project. Surprise, surprise, students were more enthusiastic when they were able to choose a topic. Oh my God! Groundbreaking here. Yes, students loved going ahead and picking their own topic as opposed to having something assigned to them. The other thing is they also loved working on a complete project instead of a module. A lot of the grumblings, a lot of the main complaints we hear from our students was that we currently teach, how we teach computer science in our community college is on a modular basis. And the reason why we do that is that we're trying to mirror the industry. The industry right now, unless you're the owner of the company and unless you're a really, really small shop, you as a programmer don't work on the entire project from start to finish. What happens is, just for security reasons, to keep people from adding back doors or having other people know exactly how to, you know, create a clone of what your game is or a clone of what your product is, what most will do is they actually will piece out modules. So someone will do data arrays, somebody will do user interface, somebody will do you know, how do we handle loops, and how do we handle structuring or architecture. And so you have different people working on different things, and they're all under contract, or maybe they're employees of your company, but nobody really works on the project from start to finish. What you do is you cobble everything together, which is why when we looked at our learning management system, why the dating was off, because it all depended on the programmer, who wrote the program, of what dating preference they wanted. And it wasn't like there was a consensus by, you know, the overall company to say this is what we're mandating, that you have a common dating system. So that's the other piece to it. They really loved working on a project from start to finish. It gave them more investment. They were more invested in it. Almost every single event we had, students were always coming up afterwards and saying, hey, if we just had 12 more hours, or we just had another hour, we'd go ahead and we'd be able to finish this. And they wanted to do it. And some of the students actually got together outside of this event, after the event had happened, and actually started working on trying to complete the actual projects. The other thing we had here were more students showed up for required events than voluntary events. Surprise, surprise. If you required them to go, then they would show up. If it wasn't required, then we had a lower number of people attend for the voluntary. And yes, it was an alternative assignment, as I said earlier, but we also experimented with that. So also our instructor made some of the face-to-face instructor made some of the events required for the students, and then afterwards, that was the first event was required for her class, and then afterwards it was more voluntary and more of an alternative setup. But for online, it was always an alternative. So other thing we saw, high student retention in traditional course. We had lots of students. We had 25 students attend the first 24-hour hackathon. Of those 25, 24 returned to the next step class. The only reason why we lost the one was because he was hired to do programming. So he decided to go back into the workforce as opposed to continue his degree, and he actually had achieved his associates already. Someone with got a program job with an associate's degree. So that was really cool. It's a really great reason to not have it to lose a student because of placement, but we had very, very high student retention. Also, the thing we noticed in class was students that were actually involved in the class were way more socialized, way more engaged in the course materials after each event. They were asking better questions, more in-depth questions. They were referring to some of the issues that they ran into during the actual process. And so we definitely had a lot more engagement in the topic after the events. And also it carried over to the next lockstep class as well. The students were reading the course materials before the class, and they were asking deeper questions about the material contents. What's interesting, though, is that students seem to prefer the shorter sessions as opposed to the 24-hour session. The 24-hour session was an awesome group building project. We had lots and lots of great interaction, lots of friendships were formed, lots of relationships were formed there. The shorter sessions, it was much more focused on just accomplishing the task. And it was interesting, students liked that better overall. They gave their satisfaction with the shorter sessions higher. Now, part of that is probably because they didn't have to stay up all night. They didn't lose a day. They were able to come in like a normal day and work typically what you consider normal working hours, and then they were able to go home and sleep in their own beds as opposed to a hard floor. Campus space is way more affordable, and food costs could definitely be offset by potluck or a food break. Yes, there's a comment here that says, sounds like this could work as a regional competitive event, sort of a tournament-like. Exactly. A lot of hackathons are set up that way. If you can get the sponsorship, a lot of companies will try to get sponsorships. A lot of the groups that set up hackathons try to get sponsorships to award prizes. So what will happen is first through third, and it'll be voted on by a panel of judges, would go ahead and the first or third product would get prize money, whether it be money, whether it's free software, things like that. But unfortunately for us, it was mostly class focused, so we didn't really make it a competitive event. I mean, there was a little bit of competition as far as when the students were pitching their games to each other, as far as what game they wanted to create for the second hackathon. That was a bit competitive, but the person who won actually sort of had the hands down majority vote, and it was almost unanimous that people that wanted to vote for that one. So there's some different pieces that you have, but yeah, definitely I think it could definitely be a state event, and that's something we're investigating now is how much more do you want to do and get more student coding clubs involved. The other thing we noticed was that students increased their interest in other areas of computer science beyond coding. So we had some students who realized after the hackathons they weren't interested in being a programmer, but they were interested in being a supervisor of programmers, or they wanted to be a manager, they wanted to be a project manager, they wanted to be a digital artist, or they wanted to create the actual character and create the wireframes for the animation. And they wanted to do different pieces like that. So it was really an interest beyond just coding. A lot of people were interested. Some people were more interested in the networking aspects of coding and of the hackathon and the games they were creating. And some other people were more interested in just looking at how can we go ahead and actually run a hackathon. We had some people who really liked it as an event. Again, students really enjoyed being able to move and reorganize. So if you are going to provide them space, try to give them as much movement as possible. The computer labs, obviously not a whole lot of movement in those areas, but we had a lot of breakout rooms, so students could actually spread out and move tables and do different things like that and sort of form their own groups in different areas. So those little nooks and crannies and little niches around your office or around your school, those are awesome places to put furniture, to put seating so the different groups can break out and get away from the computer to have the discussions and get back. We also found that there was a need for a strong student or faculty mentors to maintain focus and be the guide on the side. And the reason is that a lot of our students, a lot of our students were just starting out in computer science. Again, we're talking about the Computer Science 1, Computer Science 2 students. So they do need some direction. They're not self-directing yet. So especially on projects they didn't choose the topic on. They needed a little bit more guidance for those ones than they did for topics that they really picked, because they were doing a lot more research and a lot more things for the topics they picked. So now I'm going to turn back to Kay to talk about assessment considerations.
Okay, when it comes to assessment considerations, this was brand new for us. What we really did was we went with a clipboard with our for community college, we have the Common Core numbering system, which says the topical outlines that you're supposed to have in a class and exactly what the competencies are. And went with a clipboard and a checklist, and I took notes, took videos, and afterwards we went back and looked at it to see exactly where we could align it to what was required in the class. And basically, we hit at least about 50% of the competencies being able to be assessed just from this. And we really like that. We also did pre-surveys before the students started, post-surveys, and that's where we got a lot of our stats and our ideas about how the students liked it. And then we also did interviews with the instructors to find out what the instructors who were there to find out what they saw and their observations afterwards in their class. So that's how we assessed the project, and like I said, when it came to the actual class, how we assessed inside was watching. And as an instructor, you can base assessments on observations when you actually see the competencies happening. So that's how we did it.
Thanks. And so this is sort of the end of the presentation. We actually opened the floor up to the participants who are out there at the event in ISTE. Definitely welcome your guys' thoughts and comments, either in the Games and Sim community or also going ahead and responding to the Padlet. So thanks everyone for watching, and thanks everyone for your comments as well and questions.